So in this video, I'm going to be showing you the really easy way to learn some of the very high-yield visual field defects. When it comes to understanding the visual field, you should just draw it like this. You've got an eyeball, the sort of socket that the eyeball sits in, and then these are the paths that receive different innervation. And the way that this is going to work is we're going to have the left side and the right side. And the way to remember this is to just say that left goes left and right goes right. And that'll make more sense in a little bit when I start drawing these pathways in. But basically what's going to happen is that you're going to get from both sides, the left side and the right side, you're going to get feeding of nerves into this socket area. And once those nerves reach the socket area, what you need to know is that whatever ends up on this side of the socket, and I'm using that term loosely in sort of a layperson term, it's actually going to project to the opposite side of the eyeball. So whatever ends up on the left side of the socket projects to the right side of the visual field. And likewise, whatever ends up on the right side of the socket is going to project to the left side. So they kind of crisscross here. So the nerves that land here are responsible for the right side of the eye, for the right side of the visual field, and whatever lands on the right is responsible for the left. Same thing on this side, right? So anything that ends up on the right side is going to contribute to the left side of the visual field. And anything that ends up on the left side of the socket is going to go to the right side of the visual field. So understand how that crisscross works, and then I'll show you an example of some visual field defects after we draw in how these are projecting. So now let's draw in the projections from the left side and the right side. So I told you already that the way to learn this is to say that left goes left and right goes right. Now basically what I'm referring to is that from both sides, from this side on the left and from this side on the right, you're going to have two different tracks, if you will. So orange is going to be used for the left side. So left goes left. So you're going to have two different orange lines that are going to come up like this. Okay? Now here's where they split. One of the orange lines, which is innervation coming from the left side, is going to go to the left eye. And the other orange line, the innermost one, is going to go to the right eye. Now, but what you need to remember is that left goes left and right goes right. So because both of these nerves, if you will, are coming from the left side, they're both going to end up on the left side of our sockets. So they're going to end up on the left side here, and they're going to end up on the left side here. So now we just need to draw how they actually get there. So left goes left and right goes right. So left goes left. So that's where it ends up. Now the outside one, the outermost nerve, goes to its ipsilateral eye. The innermost one coming from the left is going to cross over, and because it's going to end up still on the left side, it has to kind of hug the center here and go to the left side. So left goes left. Anything that originates from the left side always ends up on the left side of the eye socket. And then because I told you that there's a crisscrossing, it's actually responsible for this half of the visual field. And because there's a crisscrossing, it's responsible for this half of the visual field. So that half of the visual field here and here on the right sides is actually coming from the left. So left goes left, left goes left. And because it crisscrosses, it's actually controlling the right side of the visual field. Now let's do the right side. So if left goes left, then right is going to go right. So just like we had two orange lines on the left, we're going to have two green lines on the right. So these are both nerves, if you will, coming from the right side. Now because right goes right, we know that these green lines will eventually have to go on the right side of the eye socket and on the right side of the eye socket, okay? So somehow these green lines have to reach their destinations. And if you remember from our left side, the outermost nerve, which you see here, is going to just stay on its ipsilateral side. And it's going to go up like that. And the innermost part of the right side is going to cross over and end up on the right side of the socket because right goes right. Right goes right. So even though it's coming both from the right side, it's going to end up on the right side of the eye socket. And because there's some crisscrossing from the eye socket to the visual field, this nerve is going to cross over and control this part of the visual field. And on this side, this nerve on the right side is going to cross over and control this part of the visual field. So this is where the visual field is getting its innervation from, if you will. And I'm using terms very loosely here to just help you understand where this is derived from. If you understand this, you should be able to get every single problem that they're going to ask you about visual field defects. And let me show you an example. Our first example will be if we have a knockout or a defect right there. So number one is a defect with the right optic nerve, okay? So if we knock out the right optic nerve, how will our visual fields change? Well, let's see what can't connect to the eyeball. There's no problem with the left eye, right? Because the left eye gets all of its innervation. Let's follow the green line back from this side, and there's nothing blocking that line. And this part, the orange part, comes from right here. And there's nothing blocking that green line or that orange line. But there's going to be a problem with the right eye, okay? Because if we follow back where this right eye is receiving its innervation from, you can see that the orange part comes from here, which came from the left side. Left went left, but it can't get past the knockout, because if we make that cut right there, then this part of the orange line is not going to be able to get through to the socket and then crisscross into the visual field. Likewise, the green part of the visual field came from right here, and if we follow it back, it came from our right side, and right goes right, but right here, it can't pass through. So what's going to happen? If green can't make this part of the eye field, then we don't see this. And if orange can't make that part of the eye field, we don't see this. Therefore, if you have a right-sided optic tract knockout, you have one visual field that's all black, as you see here, and one that's totally normal. So, you know, when you look in review textbooks, you'll see something like this. One all black on the right and one normal on the left. That's what happens if you have this knockout. Now let's do another example. What if we have a knockout right here, smack in the center? So we'll call this number 2. So let's see what's going to happen here. Now, I didn't do a good job of drawing where the orange line and the green line should cross. This area should actually be right there, but you get the idea. So if we knock out number 2, then we're going to have problems in both of our eyes, because as you can see, there's some crossover right where the knockout occurs. So let's see what's going to happen. Well, left goes left. So let's start with our left side. This orange line can get to the left eye, cross over, and do the medial portion of the left eye field with no problem. But this orange line is, left goes left, so it's going to end on the left side of the opposite eye. So if we follow it up, then right where that orange line gets crossed over where the knockout is, right here, we're going to have a problem. So this will never make its way to the socket, which means it can't cross over, which means we don't see this. Orange line never gets to the opposite eye. Now let's look at the right side. Right goes right. So we follow this green line, and it does make it, no problem, to the right side of the ipsilateral eye. But the innermost part, right goes right. So this part from the right still has to end up over here on the right, but if we follow it, right where it goes through the knockout, right here, it never reaches this. Therefore, it can't cross over, and we don't see the lateral part of the contralateral visual field. So we can't see out of the sides, but we can see the medial portion. So you may have seen this depicted like this, where you cannot see your lateral eye fields. This is called bitemporal hemianopsia, and this is due to the lesion that you see here, right in the middle. Now, bitemporal hemianopsia, which you see here, is due to that lesion at the optic chiasm, and the optic chiasm is where these different paths cross over smack in the middle. So high-yield optic chiasm lesions result in bitemporal hemianopsia. And I'm just showing you with these orange and green lines how this is derived. It makes a lot more sense if you follow the tracks. Now, the last example that I want to do in this video is a knockout right here. Now, this is the right optic tract, number 3. And earlier, I misspoke a little bit. So this part is the optic tract, and this part is the optic nerve. So we did an earlier example where there was a knockout right here. That's the optic nerve. A knockout right here is the optic chiasm, and a knockout either here or, if we're doing this side right here, that's the optic tract. So number 3 is a knockout of one of the optic tracts. Now, to figure out how this will affect our visual field defects, all we have to do is continue our theme of following the lines that can't make it through the knockout. So let's start, and I know this is going to get a little bit repetitive and a little easier for you, but that's a good thing. So let's start with the orange lines. Do the orange lines get impeded at all? Well, the answer is no, because the orange lines don't cross over a knocked out point. So the orange lines come from the left side, and left goes left. So left and left. So the orange on this side is good, and the orange on this side is good. Now let's follow the green lines. Well, this green line can never get where it needs to go, and this green line can never get where it needs to go, because right here and right here, we have a knockout. So both of our nerves coming from the right can't, project to the right side, the right of this socket and the right of this socket. And because of the crossover that I told you about earlier, right can't cross to left, right can't cross to left. So the green never gets to the eyeball, and we knock out the green part of our visual field. Therefore, this is what you have: the left part of the left eye and the left part of the right eye. So, when you're studying, the way that it will be listed or shown will be like this. You will not be able to see the same part of both eyes. Now, the term for this is really hard to pronounce, and I'm going to do my best here. It's a contralateral Homonymous Hemianopia. And all that means is this: you can't see the same part of both eye fields. But it's not lateral, right? It's not the right part of the right eye and the left part of the left eye. It's the left of both, or the right of both if the knockout was on this side. So that term is very important to know. Now, in this video, we've done a knockout here, we've done a knockout here, and we've done a knockout here. I want to end this video by saying that those are the 3 highest yield knockouts that cause visual defects that you could be asked on USMLE or COMLEX. Certainly, there are more knockouts that can contribute to visual field deficits that you should be familiar with. But I'm not going to cover them in this video because things will start to get really complicated, and I want to keep this video simple, stupid, and easy. If you know these 3 knockouts, you will get most of the practice questions correct. And if they're going to ask you about any other visual field defect, I would argue that if you don't want to study, it's simply not worth memorizing. This is where the bulk of your questions will come from: optic nerve, optic tract, and optic chiasm. So know these and you will do very well.